Welcome back to Joe's Computer Museum. Today we're going to repair my very first computer, the TRS-80 Model 1. Warm up the CRT, it's time for another episode. The TRS-80 Model 1 was the first computer I ever owned. That old thing had its share of problems and failed many years ago. But when an opportunity came to buy this TRS-80 from a local Ohioan, I couldn't pass it up. This old thing had tons of problems. They don't call them Trash 80 for nothing. But being my first computer experience, I just had to fix it up. So what is the TRS-80? The TRS-80 microcomputer system is a Z80-based computer released in 1977 by Tandy and sold by Radio Shack. It's a member of what has been called the 1977 Trinity of personal computing, sharing the title with the original Apple II and the Commodore PET 2001. The TRS-80 was many Americans' first exposure to computers and the industry's first hit product, outselling its competitors easily until 1982. It started in the mind of Tandy buyer Don French. Influenced by the MIT's Altair, he designed his own computer and showed it to Tandy management. They loved the idea of a personal computer and they ran with it. Don teamed up with Steve Leininger of National Semiconductor, having found him working part-time at the Byte Shop. Their big idea? Design the machine as a finished unit and sell it pre-assembled. Just hook it up and go. But Radio Shack had a big problem. Their average product cost only $30. The TRS-80 would sell for over $500 in a standard configuration. They weren't certain their normal clientele would drop that much cash on such a high-ticket item. It was a big risk, so they made a compromise on production. An initial run of 3,500 units, one for each Radio Shack store in America. If the machine flopped, they could use the unsold units to manage store inventory. But Tandy had an ace in the hole. As an established electronics powerhouse, they had both manufacturing and distribution locked down. Despite announcing the TRS-80 in August of 1977, months after the Commodore PET, they beat it to market by nearly a month and had units in consumers' hands by September. Despite an initial estimate of 3,000 units a year, Tandy sold nearly 7,000 units in the first month alone, and went on to sell over 200,000 units over the computer's production run, making the TRS-80 one of the most important 8-bit computers in history. Let's take a look at everything I got with this fantastic old machine. I got the computer unit and its power supply. The system didn't come with the original monitor, so I borrowed one from an Apple II temporarily. I know, blasphemy. It did come with a universal composite cable though. It has the expansion interface and original interface cable, but the power supply is missing. An aftermarket cassette deck and cable. An aftermarket floppy drive and a cable that doesn't exactly fit. Level 1 basic instruction courses on cassette. And finally, Double Back, a TRS-80 color computer cartridge. Not sure how that got in there. What are we waiting for? Let's get started. First, let's check out the condition and give the outside a look over. The case is warped. There are some cracks and repairs to the port panel. The machine is missing the bottom label and has also received an aftermarket paint job. And of course, it's missing the expansion port cover, because they all are. It's seen better days, but it's a Model 1, so we can't expect too much from it. Now let's get into the guts and see how she fares. Rule number 1, thou shalt test voltages. Before doing anything, I tested the power supply. I got both AC and DC voltages close to where they should be, so the power brick is good. Rule number 2, don't turn it on. Take it apart. I had to peek around for anything obvious. Loose metal, charred chips, weird smells, anything out of the ordinary. Everything looked okay to me for the most part. I did note the keyboard cable had been fixed pretty messily by a previous owner. We'll address that later. I discovered the machine has a level 2 ROM upgrade. Bonus! And based on the newest date code inside, it was built in mid-1979. Rule number 3, give it a go. So what do we have? We have a mess, that's what. Rolling screen and horizontal bars. But there's nothing on fire, so we're ahead of the curve. My first suspect is a cross short on the keyboard cable, so I jiggled that. No joy. Next I checked the chips for overheating. Nothing was too hot, so the chips are at the very least not shorting out. Next I pulled the processor to see if I get any change. I get rolling in garbage instead of horizontal bars. I'm not sure if that means anything, so the processor went back in and nothing changed. Next, I checked the ROM cable. There's a bent pin on pin 7. I checked around the internet to ensure it didn't have to be that way, because TRS-80, and didn't find anything. So I bent it back in place and presto, we have a heartbeat. We still have some rolling on the screen, so we'll get to that next. I played with the vertical positioning pot, but that didn't do anything, indicating a problem with the vertical sync circuit. Let's look at the schematic and see what might be the case. Probably chips Z5 or Z57. I probed Z57 and I'm not getting what I should. Pin 1, signal. Pin 2, I don't know what the heck that's supposed to be. Pin 1 should be inverted and come out pin 2, but it doesn't. I think Z57 is bad. So I ordered a 74C04 chip to replace it, and bingo, it works. I also replaced Z5 and Z6 while I was at it, since they are part of the same circuit. The likely cause of this problem was someone plugging the power into the video port. They are next to each other and use the same connector type, so it's easy to mess up. Great design choice, Tandy! On power up, I still have occasional issues with random garbage on the screen, and looking at the keyboard wiring, although it has been repaired, it wasn't done very well, and there's some tendency for wires to cross-connect. Way too much solder in some places, exposed sections that are too long, and some wires that are almost snapped through. So I desoldered and trimmed the problem wires, resoldered them all in place, then hot glued the connectors so they can't wiggle about. Next, I replaced the sticky pads holding the ROM upgrade to the board. They had fallen off before and were reaffixed with hot glue. By the way, when you need to remove hot glue, use isopropyl alcohol. It will not dissolve the glue entirely, but it will loosen its bond with the surface, and it peels right off. I was unable to remove the residue of the original foam pads. No solvent I had that I trusted to use on the board loosened it up. I replaced it with some super sticky 3M tape, doubled up, and that did the trick. While I was in there, I replaced the large power supply capacitors. Finally, I set about fixing the binding posts. They were all messed up. Someone tried to repair the cracking with electrical tape. I added some strength to them with zip ties. It wouldn't be a TRS-80 if some of the keys on the keyboard didn't work, so I worked on those next. To start, tweaking one of the fingers does wonders to cancel out key bounce. Then I cleaned any tarnish on the contacts with 800 grit sandpaper. A couple of the keys required resoldering on the back of the board. Now I have to work on the expansion interface, but before I do that, I have a little challenge to overcome. I only have one power supply. The main unit and expansion interface, or EI, use one each of the same supply. No worries though, we'll make one that fits inside the EI and will power both units simultaneously. My experience with AC and analog stuff is nearly non-existent, so let's see if someone smarter has already designed one. Sure enough, Dean Bear and Ian Maverick have, so I followed their schematic and some notes from TRS-80.com. I threw parts on a board and wired it up, hooked up the leads to the board, then soldered the plugs to the leads, crimped them down, and put on the jacket. Looks pretty good. Now let's test the voltages. It all looks good. So does the new supply power up the main unit? Sure does. Awesome. Now we have to fit it to the EI. Let's cut a notch in the board, add some legs so the high voltage leads don't touch anything, and install it in the EI. Bingo! Finally, we can get to working on the expansion interface. Same protocol applies here. Examine the outside, check the inside, then fire it up. This one actually has the model and serial sticker on it. It looks like it's a factory plain expansion unit with no RAM. This too was repainted by someone, judging by the paint over the remains of the warranty sticker. Of course, it's missing all of the cover plates. They almost always do, so no worries there. And there's a bit of warping near the front. Not too bad though. I popped it open and looked at the plastic shells. Date codes. So this was made sometime in August of 1980. The board looks really clean, and we can see it's the newer buffered model, and it's had a 32K RAM upgrade. The big power capacitor is shot, but it'll be fine for basic testing. I replaced those later. So let's hook everything up with the new supply and see what happens. Big fat nothing. What could be wrong? So let's spend 6 hours diagnosing every possible thing and chase ghosts all over the place when all I really had to do was read the manual. When you boot the EI without floppies, you have to hold down the brake key. Now that I have that time-wasting maneuver done, let's power it up the right way. Bingo! Works perfectly. As a part of the diagnostics process, I replaced the card edge connector with header pins and a modified parallel IDE cable. The original cable is splitting apart, and this new cable should offer a much more reliable connection between the units. Now let's see if floppies work. I don't have any, so let's download and write one. First, grab a floppy image. I downloaded new DOS-80 from Willis.com. Write it using Dave Dunfield's image disk on an old DOS computer using an authentic 360K drive. And there you have it. I used new DOS because the official TRS-DOS uses some data structures peculiar to the floppy chip in the expansion interface that PC floppy controllers can't read or write. Now it's time to take a look at the floppy drive unit. The floppy unit is an aftermarket Computer City CCI-100M. Fairly clean on the outside, but obviously repainted. Apparently the whole thing must have been. I can't find anything on the manufacturer of the entire unit, but the drive unit inside it is the Microperipherals Model 5152, usually associated with OSI computers, but also loads others. It's a standard single-density Shugart compatible unit, so it's fairly universal. The inside looks pretty good for what it is. Not too nasty, almost no dust. First, check voltages. They look good, no problems there. So let's hook it up to the computer. The first power-up will be with the head cleaner disk. We don't want to kill my nice new disk. Uh-oh, the drive lights up, but doesn't spin. Let's start diagnosing. First off, does the drive motor run? Yep. Next, does the drive transistor have 12 volts on the collector? Nope. As a matter of fact, the 12-volt line is drawn low across the board. Even though the power supply tested as good, let's test the drive unit with a known good supply to see if that fixes it. It's the opposite of fixed. I wasn't rolling the camera, so let me simulate that for you. That's capacitor C31, cross the 12-volt rail right at the power supply input. I should be able to cut that out and test again, since it's just used for noise suppression or decoupling. We check the voltages again. All good. So let's order some parts, throw them in, and see if the drive is fixed. Yes, it spins. Now that the drive head is clean, will it boot? It sure does. Now that we have that going, let's test the cassette system. I'm sure it works, but the process won't be complete without testing it. Yep, it works just fine. Well, that was an adventure. I enjoyed fixing this old girl up and getting her running again. Seeing the memory size prompt brings back lots of great memories, and I look forward to getting reacquainted with my old friend. For a step-by-step process of writing floppies for this old beast, check out the description for links, especially Adrian Black's awesome video. And special thanks to my patrons on Patreon. I couldn't do this without you. Well, that's all for today's episode. While you're here, check out some of my other videos, and remember, 8 bits are all you need. Thanks for watching. If you want to help out my endeavors, head on over to Patreon, pick a tier, and get cool stuff, like early access, behind-the-scenes videos, your name in the credits, and gadgets. Link in the description.